Mr. Sams, you've been in a kind of sour mood lately.
Yeah, kind of sour.
Yeah, what's going on, man? How come you're so sour?
Well, I hurt myself.
Yeah.
Kind of in a cranky mood.
Yeah. Hey, sour. Sour. Hey, that kind of goes along with what we've been talking about. So maybe it's like appropriate that you've been sour.
Well, maybe.
Yeah. So let's see how that goes. Hey, today, folks, we're going to be talking about acids and bases. And guess what acids are? Sour, like old sourpuss right here. So hey, let's learn about acids and bases. Yeah. Oh man, look at that face. Only a mother could love it. All right. Hey, I think we should learn a little bit about acids and bases.
Okay.
So common acids and bases. So let's do a little video clip about common acids and bases.
Alrighty. Alright, welcome to Unit 10. Here we're going to be talking about acids and bases. Now, there's a lot of really common acids and bases that you'll find around your house and, around your school or wherever, grocery store. So if you think acid, don't think like nasty stuff that'll burn your face off or anything like that. Now we have some of those down here in our acid cabinet, and I'll show you those here in just a minute. But some common household ones that you have laying around, vinegar. Vinegar is an acid, okay? Very common acid that we have around our houses. In your soda, okay, I got a little bottle of Sprite here. If I read the ingredients, we have carbonated water, high fructose corn syrup, citric acid, okay? Citric acid, it gives it a little bit of a tang, kind of a, nice little zip, tangy sourness to it because acids taste sour. Some common household bases. You can have household ammonia. This is a cleaning agent. Baking soda. Baking soda is a base. Okay, it's a weak base, so it's not like something, again, that's going to be nasty and horrible that you need to be super careful with, but it's a base nonetheless. Something called washing soda. These two are cousins. Baking soda is sodium hydrogen carbonate, and washing soda is sodium carbonate. Okay, Tums antacid. Okay, it's called an antacid or an anti-acid because it's a base, and bases neutralize acids. So, a little antacid you can take if you have an upset stomach or anything like that. And you're sometimes in our class we analyze this as our final project. So, just heads up there. Now, some of the more commercial things that we buy here in the lab are things like sodium hydroxide. Now, these are sodium hydroxide pellets. Now, sodium hydroxide is a very strong base. We'll talk about what that means in a while. You can see it comes in these tiny little pellets here. Okay, we're very careful with this because the powder can kind of poof out and be nasty. We don't want to breathe that in. We'll take you down into our corrosives cabinet here. This is our acid cabinet, if you will. We've got a little cube here. This is where our nitric acid lives because you've got to keep nitric acid by itself because if it's around acetic acid, it can actually form some really nasty compounds. So put that in there. Hydrochloric acid, you're going to use a lot of hydrochloric acid. It comes in a big jug like this. We don't let you play with the nasty jug because this stuff is horrible. We always open this underneath the fume hood because it smells really bad. It has some chlorine vapors, HCl vapors, things like that. So Mr. Bergman and I will handle this. We'll give you a more diluted version. This is a 12 molar hydrochloric acid, which is about as concentrated as it comes commercially. We've got sulfuric acid and things like that in there. So typically, our strong acids and things like that we keep in here, in our corrosive cupboards. Weak acids not as important, but we do keep some weak acids in there. But a lot of the common household items are weak acids. I'm just going to wash my hands real quick because the next thing I want to do is have a little acid snack. Think of my pocket here. You guys ever had a warhead? Extremely sour. If you read the ingredients list on warheads, it's pretty ridiculous. It's mostly sugar, and then you've got malic acid, citric acid, and ascorbic acid, which happens to be vitamin C. And that's what is on the little powdery thing around here on the outside. So if you know anything about acids or anything about warheads, if you put malic acid on something, oh my gosh, and citric acid is ridiculous. Holy cow, I can't even talk. It's ridiculously sour. Oh God, horrible. So acids are sour. Never forget it. If you taste sour, you're tasting acid. We'll talk about how it works in a little bit. My eyes are watering. My mouth is watering when you're drool. Let's get to learning some actual things instead of watching Mr. Sands make horrible faces. Oh my gosh. It's awful. Okay. Or okay. Better. The end.
That was pretty cool, Mr. Sams.
Yeah. Lots of acids and bases all over the place.
Boy, they're really amazing, aren't they? Okay, speaking of acids, bases, we should learn about the properties of acids and bases. So what do we know? First of all, I know that acids, well, they're kind of sour, like you've been lately.
About that,
yeah, they're sour. They taste sour. Ooh, ooh. Yeah, like a lemon.
Yeah.
An example would be what?
A lemon.
A lemon, yeah. Anything else that's sour tasting?
That warhead I ate.
Yeah, warhead.
Yeah, those things are horrible. Got citric acid and malic acid and all sorts of...
Yeah, nasty stuff.
Yeah, vinegar.
Yeah, vinegar. Okay, good.
All right, hydrogen ions.
Yeah, very important to understand, folks, is that it's the hydrogen ion. When we say hydrogen ion, that's H positive.
Mm-hmm.
That's the hydrogen ion.
Yeah, they... yeah, we'll talk more about that
Yeah, a
later.
little bit later.
Acids tend to be corrosive.
They're
They
also
can
corrosive.
dissolve metals and can sometimes break down plastics, and
Yep.
they help some enzymes work in your stomach, things like that. So
They're very important, and a lot of people think of acids and they get kind of all freaked out.
Yeah.
But there's a lot of acids that are very important and common. Some are used for cleaning agents like boric acid.
Yes, and they don't always turn things into evil superhero villains or anything like that. So.
Yeah. So and sometimes even at the eye doctors, they'll put acid in your eye to help. I think it's boric acid.
I'm not sure.
They use some kind of real dilute acid and weak acid, and so it's not.
They're not bad.
They're not bad. There's some that are very bad.
There's
though.
some, yeah.
Yeah. Okay.
Yeah.
And then bases.
Yeah, those tend to taste bitter.
Bitter.
Yeah, they actually, and when you touch them, they feel slippery.
Yeah.
Now, I've heard reasons for why this is the case. I don't know if it's 100% accurate or not, but I've heard that since you have oils in your hand, when you put a base on an oil, it actually turns it into soap.
Oh, that makes
so
sense.
it's a process called saponification, and so I've heard that you're actually turning the oil in your hand into soap, and that's what feels slippery. I'm not exactly positive, but
That makes sense,
I've
though.
heard
Yeah,
that
I
in a
understand
workshop
that.
somewhere.
And they produce a chemical called hydroxide. Remember, that's hydroxide. That's one of those polyatomic ions we learned forever ago now, it seems like.
Yeah. Now, bases can, if we're talking about nasty acids, there are just as nasty bases as well.
Bases can be very dangerous.
But there are also some that are not dangerous in any
For example,
way.
like what?
Like baking soda is basic, but
Yeah.
that's obviously you eat that, so that's not a problem. Yeah, so
There's also bases like in DNA and stuff, right? Base pairs.
yeah. Those just have nitrogen in them, and they classify as bases that way. Yeah,
So there's also some very helpful bases. So yeah, some bases are nasty, horrible, and some are
not so bad.
not so bad. In fact, are essential for life.
Yeah.
Okay. Hey, let's just talk about your taste buds. Interesting,
Okay.
acids and bases in your taste buds. Not just acids and bases in your taste buds. You've got the tongue. This is a tongue. This is Sam. What are you doing with the tongue?
Hold on.
Okay, that's gross.
Yeah, I
Okay. All right, so that's a tongue, if you didn't know that. And you probably know that you have things called taste buds.
Yeah, they're little bumps on your tongue.
And the little bumps on the back of your tongue, those are the bitter taste buds.
Yeah. And now we're going to kind of generalize here.
Yeah.
They're not completely isolated to these areas, but the general idea is that they're kind of more concentrated in these areas.
Yeah, you can taste essentially 4 different types of things with your tongue. Sweet, and then that's at the tip of your tongue, ish. That's sort of an ish thing. And over here on, I forget, where's the sour versus
And they're
the
all,
salty?
I don't remember. They're on the sides, both
On
of
the
them.
sides
Yeah.
are your salty and bitter. So let's just say, for the sake of argument, Mr. Bergman, you're wrong.
Yeah.
This is the salty, and then this is the sour.
Yeah, and again, these are generalizations. They're not completely isolated to these locations.
Yeah, but they're sort of ish. Yeah.
Yep.
Now, what is it that your taste bud does?
Yeah, well, when we talk about acids and bases, we mentioned a minute ago that acids are sour. So when your sour taste buds are going off, what they've done is they've detected the presence of hydrogen ions. If you have hydrogen ions, you have acid. So it goes sour, hydrogen ion, acid.
So think of it this way: if you've got in my house, I've got what's called a carbon monoxide tester, CO, carbon monoxide, and the job of that device is to sniff all day long, all night long, 24 hours a day, 7 days a week for carbon monoxide. If carbon monoxide gets burned from my furnace, it's not good to have carbon monoxide in your house.
Nope.
Then it beeps and makes a horrible, god awful noise that says, "Get out of your house."
Get out of your house. Yes.
All right. Essentially, that's what your sour taste buds are doing. Is all day long, 24/7, they are waiting for a hydrogen ion to come across them. When it does, it sends a signal to your brain saying,
Sour.
"Sour."
Acid.
Yeah.
Yep. All right. Now,
And so it's just a specific detector for a
Right.
specific chemical.
Right, exactly. So the bitter ones are actually detecting bases. Now, they don't really detect hydroxides. They're actually detecting things that have nitrogen in them,
Yeah.
and things with nitrogen in them tend to be basic.
Yeah.
So that's really what they're detecting.
They're detecting bases, but
Right.
it's not quite as specific. It's looking for a particular chemical
Right.
that's related to the chemical that makes
hydroxides.
bases
Right, exactly.
hydroxides. But it's
Yeah.
not exactly a hydroxide tester. And frankly, the same things. The sweet is looking for chemicals that detect sweet. This is the most complex one I understand biologically, because there's so many things that can taste sweet.
Yep.
And then the salty one is actually, while we're at it, is detecting either sodium ions or potassium ions.
Yep.
So those are the two things it's looking for. So the ones that are sort of the pure ones, they're looking for just very few chemicals, is the salty tester and the sour tester.
Yeah, the sweet and the base ones,
A little
sweet
more
and bitter, are
complex.
a lot more complex.
An interesting thing, too, about the bitter, while we're at it, is that I understand that the bitter taste buds, you can detect like 1,000 times less concentration than, say, the rest of them.
That would make sense. They actually have a compound out there called Bitrex, and they put it in things like antifreeze and cleaning compounds, so that like if a little kid tastes it, it'll taste horribly bitter, and they'll instantly spit it out, so they don't go drinking your Drano or anything like that.
Because one of the dangers, of course, is that most bases are more likely, at least, to be some kind of a poisonous substance, and so your body has adapted so that it has
It goes,
1,000
bitter,
times bitter.
that means poison,
get it
out of here.
So you've got kind of it's a gatekeeper to say you don't want that in your body, and you don't.
Nope.
So hey, we've said this already, and very, very important. The most important thing in this podcast: acids make
hydrogen ions.
Hydrogen ions in water. Now, let's talk about what a hydrogen ion is. When I say H positive, if you think about that, that means there is a hydrogen has one proton. Because it weighs 1 and has an atomic number of 1. It has 0 neutrons. Now, when you have the positive 1 charge, that means it's lost 1 electron, so it's 0 electrons.
Right, so it's just a proton. That's
so
all it is.
Important to understand that, a hydrogen ion is a proton by itself.
Yep, and sometimes we call them that we'll say,
a
instead of saying
donor.
a hydrogen ion, we'll say proton donor. Yep, but we're talking about the same thing.
And bases make hydroxide ions. We talked about that.
Sometimes directly, sometimes indirectly.
Yeah,
but ultimately you get some hydroxides.
Yeah. And we'll learn about the direct, indirect thing a little bit later.
Yep.
We've already done this, but it's probably good to kind of review it. How do we name acids? So if something ends in ate, then it becomes an ick.
Yeah, so like if you have the nitrate ion.
So if, let's say I have, now actually we should make an important point. Acids always have H positive, hydrogen ion. So when you have the nitrate ion, which is NO3 negative 1, and you're going to mix that with the hydrogen positive ion, that's HNO3. You've got to have that H in it or it's not an acid.
Right.
So this is nitrate becomes
nitric
acid.
H becomes ick.
Yeah, just review.
Yeah.
Actually, nitric, but nitric acid.
Right,
exactly. The word acid. Maybe you want to think about the word acid as being the H positive part.
Yeah. One other thing we should mention is that for an acid to be an acid, it actually has to be dissolved in water.
That is correct.
So if you have HCl, which is hydrochloric acid, if it's just floating around as a gas, we call it hydrogen chloride gas. But as soon as you dissolve it in water, it becomes hydrochloric acid.
So technically it has to be AQ. Everybody has to be AQ.
It has to be aqueous.
Yeah.
Yep.
And so let's do an example of the night. Let's say we do sulfite, maybe?
Sulfite, sure.
Sulfite is, if you recall from your polyatomic ions, is SO3 negative 2. Now, of course, to make it an acid, you've got to react it with H positive, so that's H2SO3. Now, again, it has to be aqueous, so let's go ahead and throw that in there.
Yep.
And his name is an ite, sulfite.
Yep, so sulfite becomes sulfurous acid. It's not sulfus acid. We put the back in there from sulfur.
Sulfurous?
Yeah.
Sulfurous.
Sulfurous.
Well, I've always called it sulfurous. Oh, well, different pronunciation.
I don't know, whatever.
The West Coast
I guess sulfurous.
I think it's sulfurous. Yeah. All right, ide. How about an ide like cyanide? That's a nasty element. You never want that. Mess with that. H positive. So HCN would be an example of an acid that has cyanide in it, and it becomes an hydro something.
Cyanic.
So this would be hydrocyanic acid.
Right. Cyanide, hydrocyanic.
I keep adding the word acid. Remember, think of the word acid as basically being the H positive part. I know the H positive part typically goes first. I don't know, it's just backwards. Deal with it.
Yeah.
So I believe that's
review.
Oh,
there's
naming.
some more examples.
We kind of did examples.
We did enough. You've done plenty
so
of these.
Maybe one go the other direction.
Okay,
Let's say
sure.
I've got H3PO4.
Okay.
What's his name?
Let's split it up. We got 3 hydrogen ions, and then we have.
So that's that H positive. That's that word acid, right?
Yep.
And then we got.
And then
PO4.
we have PO4, so that's has a -3 charge. That's the phosphate ion.
So that's phosphate.
So if 8 becomes.
So let's
ick.
go back and look at our table just in case they might have forgotten.
Okay.
And 8
becomes
ick.
So phosphate becomes phosphoric
Phosphoric acid.
acid. Yeah. Don't forget the word acid. All
We
right.
should probably do the other direction. Should I have another place? I don't, but let's do it right here.
Just
What if I have a name? Pick one, Mr. Sam.
pick one. Let's do
Some weird one.
weird one. How about hypochlorous acid?
Hypochlorous acid. All right, so we want to find the formula of hypochlorous acid. It's an us acid. There's this
Yep.
hypo thing. That's kind of weird.
Yeah.
But if I go back to my table,
Yep.
it ends
I don't
in
see anything with a
us.
hypo here. I see a hydro, but that's not hypo.
So
but I
us,
see us.
came from ite.
Right.
All right, so I see the word acid, so I'm going to think H positive, and it's hypochlorous, so that's be hypochlorite.
Yep.
So hypochlorite. Well, you just look on your polygon, and of course that is
ClO or
OCl. It's OCl.
Two ways of writing it. Yeah.
OCl
Minus.
-1.
Yep.
And those charges do cancel out to zero. Remember, you got to play the charge games. That's just HOCl. Okay,
All right.
I think we're done.
All right.
Bye.